Have you ever seen a test tube? What does it look like? Okay, here it is. It's more like a solid, completely filled up test tube. And we'll assume that it has negligible thickness. Does it look like a combination of solids? It is a combination of solids, yes. But which ones? It's a combination of right circular cylinder and a hemisphere. Their bases are congruent and the radius of the base of the cylinder is equal to the radius of the base of the hemisphere. And how was this solid formed? We placed the base of the cylinder on top of the base of the hemisphere like this to obtain our test tube. Since it's a combination of a cylinder and a hemisphere, its volume will be equal to the sum of the volume of this cylinder and the volume of this hemisphere. We have already derived the formula for volume of a cylinder in our previous videos. Can you tell me what that formula is? The formula of volume of cylinder is pi r squared h, where r is this radius and h is this height. Now we will try to find formula for volume of a hemisphere. We know that a hemisphere is exactly half of a sphere. So can you guess the volume of a hemisphere? Yes, its volume will be half the volume of a sphere. So the volume of a hemisphere is equal to 4 over 3 times pi r cubed divided by 2, which is equal to 2 over 3 times pi r cubed. So finally, the volume of our test tube will be equal to pi r square h plus 2 over 3 times pi r cubed. Is there anything that's common among these two terms? Yes, pi r squared is common to both the terms. So this can be simplified further as pi r squared times h plus 2 over 3 times r. Again note here that both the cylinder and the hemisphere have the same radius r. But what if they had different radii? What if the radius of the hemisphere was greater than the radius of the cylinder? Can you imagine the shape of that solid? Pause the video and try to determine that shape. The new solid will look like this, like an inverted mushroom. What will be the volume of this new solid? Can you derive the formula for its volume? We leave this as an assignment for you. Remember, the only difference between our test tube and this solid is that the radius of the hemisphere here is greater than this radius here. All other parameters are the same.